Sea level has changed several times in the past for geological, astronomical and climatic causes, and during glacial and interglacial periods. The study of its changes is relevant for scientific and environmental scope, and for its influence on human activities. Geomorphologic and biological indicators record these slow changes along the rocky coastlines through the notches produced by the mechanical action of the sea waves, the tide notches, and by the chemical dissolution produced by the lithodomi. These are bivalves that live in the zone between the high and low tides, and revealed that the Earth's geological past has experienced a long series of such changes. Ancient sea levels can be observed along the coast of Latium, Italy, as for example at Terracina and in the Grotta delle Capre at Circeo. Here the geologists have proved that 125,000 years ago the sea level in this area was about 9 meters higher than today. Sea level changes can also occur quickly, such as those recorded during historical times by the Serapeo, the ancient Roman market of Puteoli, the current Pozzuoli, which was submerged more times as well. Also in this case, the height at which the ancient sea level remained is testified by the holes made by the lithodomi, which can still be seen on the Roman columns. These events can be observed at Basiluzzo as well, a volcanic islet of the Aeolian Islands, which shows the remnants of an ancient Roman age pier, nowadays located at about 4 meters below the sea level. But these kinds of changes are produced by the dynamics of coastal volcanic areas, which can produce large vertical movements of the land, and consequent submersion or immersion of the coastlines. If the geology can estimate that during the last 250,000 years, the sea level has changed up to 120 meters, it is during the Tyrrhenian age, 125,000 years ago, that it reached the highest level, about 7 meters higher than today. Geological level of the Tyrrhenian, which outcrops at several locations along the Mediterranean coastlines, can be identified by the presence of the Strombus bubonius, a fossil of marine gastropoda, that lived along the coastlines during the warm climatic age, classified by the geologists as MIS 55. The height above the current sea level, at which the Tyrrhenian is found, can be used to define the values of the vertical movements of the Earth's crust of a coastal region. After the end of the last ice age, which occurred about 7,000 years ago, the sea began to rise again slowly, up to the current level. Is it possible today to estimate which has been the value of the sea level change in the recent past? A research coordinated by the Italian Istituto Nazionale di Geofisica e Vulcanologia, in cooperation with the ENEA, the Universities of Canberra, Australia, of Bologna, Tuscia, Politecnico of Bari, and the Istituto Idrografico della Marina, has integrated the archaeological, geological and geophysical sciences to estimate the sea level change during the last 2,000 years, from the analysis of Roman age remnants of maritime structures, such as fish tanks, harbors and quarries, which were built around 2,000 years ago along the coastline of the Mediterranean Sea, and that nowadays are often submerged. The Mediterranean Sea, for its rich and intense millenarian history, is an ideal laboratory for this kind of study. Coastal quarries such as those excavated in the Tufo at Ventotene in the Pontine Islands, or in the granite at Capotesta in Sardinia, show cuttings for the extraction of the carved rock, often submerged, and provide a first-hand evidence on the recent sea level change. But these sites cannot provide accurate estimations of the precise values of this change, due to the difficulty to evaluate with precision the original functional heights of this kind of construction with respect to the old sea level. Harbours and piers of the Roman age, such as those located at Ventotene, Leptis Magna, Libya, or at Capotesta, show further evidences on the sea level changes from their functional heights. The archaeological structures that more than others have provided good and affordable data have been the maritime villas, which, together with their related fish tanks, have been especially precious to study the recent sea level changes. Between the 1st century BC and the 2nd century AD, the richest time of the Roman age, to own a maritime villa, such as that located at Seripo near Gaeta, furnished with landings, nymphae and fish tanks, the latter used to provide fresh fish for food, was a distinctive sign of great wealth. Sometimes there remains only a few remnants of these constructions, such as Formia, where can still be found some pools for the fish breeding, today partially submerged and buried by modern constructions. Also, the emperors Tiberius, Nero, Domitian once owned villas with fish tanks. The fish tanks did not deserve any primary role for fish production and commerce, but they were mainly designed to be an ornament of the villas. Due to the high costs of construction and management, to own a fish tank became a symbol of social position, but as all fashions were of short duration, their diffusion was concentrated between the end of the 2nd century BC and the 1st century AD. Afterwards, these expensive constructions were progressively abandoned. The Latin authors Columella and Varrone have described with detail the architectural features of the fish tanks, still found by recent surveys at the most preserved sites, as at Punta della Vipera near Civitavecchia. These constructions were characterized by pools as deep as 3 meters.
In pedes novem defodiantur piscina.
And were provided by high external walls to protect them from sea waves.
Mox preiacuntur in girum moles, ita ut complectantur sino suo et tamen excedant stagni modum.
They had rectangular or circular plans, and were provided with precious marble, statues and columns. They were equipped with channels for seawater exchange, and testified to the great knowledge of the Romans about the environment. At Torre Astura, along the coastline south of Anzio, can still be seen some fish tanks and the harbour of a large maritime villa. Here is still well preserved the aqueduct that once fed with fresh water both the fish tank and the villa. To add clean water to the fish tank, the aquatia was used, which added a mix of fresh and salt water, very attractive for fishes such as the gilt-head bream and sea bass. Fish were bred in more consecutive pools, which communicate with each other through channels equipped with mobile or fixed sluice gates. Along the inner side of the pools run the crepidini, narrow sidewalks used to move inside the pools without getting wet and to operate the sluice gates. External walls were cut by channels equipped with sluice gates, equipped with holes, which had the task to manage the flux of seawater using tides and to ensure an efficient water exchange in the pool, but preventing the escape of the fish. Thus the Roman sea level neither should submerge the top of the channels and the sluice gates to prevent the escape of fish, nor should fall below a certain level of correct functionality to guarantee an efficient water exchange inside the pools, as described by Columella.
Spissi deinde clatri marginibus infinguntur, qui super aquam semper emineant, etiam cum maris estus intumuerit.
On the basis of these observations, and knowing that the Mediterranean Sea has maximum tide amplitudes of about 45 centimeters, the Roman sea level should be placed between the top and the bottom of the sluice gates, whose average height is generally 60 to 70 centimeters, with the exception at some sites. Thus can be determined the sea level of 2,000 years ago, with a low level of error. These architectural parts can be considered as unconventional geodetic benchmarks, which can be defined as archaeogeodetic benchmarks, being located at precise heights with respect to the sea level at the time of their construction, which have recorded the vertical changes of the land and of the sea level occurring in 2,000 years. Also, at the island of Ponza can be found more evidence of what was described by Columella and Varrone. Here can be seen some fish tanks still well preserved. The fish tank complex of Ponza was built between the 1st century BC and the 1st century AD. It consists of some indoor fish tanks and of a large outdoor one. Such kinds of structures were built at Ventotene, Baia, Capomiseno, and in other sites of the Mediterranean basin. These structures, all carved in the bedrock, display channels and crepidine, whose exploration shows an evident change of the sea level being submerged of more than 1 meter. Let's dive in a Roman Age fish tank. The entrance through the main external channel, once used to exchange water, is nowadays completely submerged. The channels between the pools. The main indoor fish tank. The crepidine, whose surfaces during Roman Age were above sea level, even during maximum tides, are well below the current sea level. The secondary channels, which now are missing of the sluice gates. Their average height was strictly related to the ancient mean sea level, in order to provide a good water exchange in the pools through tides. Also, the outdoor fish tank of Ponza shows clear evidence of the sea level changes. Another dive will allow us to touch the signs of these changes. The basement, marcapiani, of the external walls and some remnants of the crepidine. The walls which divided each pool and the connecting channels are submerged. Finally, the external channels for water exchange still provide posts that once hosted the removable sluice gate, whose base rested on the threshold. Once again, the changes of the sea level are clear. All these coastal archaeological sites of harbours, quarries and fish tanks are in agreement to confirm that since the Roman age, a significant sea level rise of more than 1 metre has occurred. But why has the sea level changed in the last 2,000 years? A first reason can be addressed to the solid Earth's dynamics. Earthquakes, volcanic activity, and the large-scale movements of the continental plates produce horizontal and vertical movements of the Earth's crust. Subsequently, along the coastlines can be observed the effects of the relative movements between sea and land, the latter submerging or uplifting. A second reason is the past climatic changes. During cold stages, when the ice sheets were extended and thick, the sea level was many meters lower than today, as occurred during the last ice age 18,000 years ago. On the other hand, during warm stages, when the ice sheets were less extended and thinner, the sea level was located at heights even higher than today, such as occurred during the Tyrrhenian stage 125,000 years ago. Today, the recent and continuous ice melting produced by the global warming seems to increase the amount of water in the oceans, whose volume changes with their temperature, as estimated by modern instrumental data. Scientists have recently related this fact to the production of natural or anthropogenic greenhouse gas, which seems to have an important role in the acceleration of the global warming process and the consequent increase of the eustatic level of the oceans. Evidence of the increasing temperature of the oceans during the last 1,000 years come from the study of the corals and by the instrumental data of the thermometers. Another reason is the global isostatic adjustment. This geophysical phenomenon started with the melting of the ice sheets after the last glaciations ended about 7,000 years ago. The increasing ice load on the lithosphere and on the underlying mantle triggered the uplift of the Earth's crust at the high latitudes, while at the lower latitudes, away from the center of the ice cap, a subsidence started. The internal Earth's mass had to reach a new equilibrium to balance the load changes at its surface. To make a simple example of this large-scale movement, let's sit on a soft pillow. The Earth, that compressed by our weight, ice and ocean load, recovers its shape after we have risen, reduced load of ice melting. This slow and non-homogeneous phenomenon, which in the northern Earth's hemisphere propagates from northern Europe to the South Mediterranean area, can be represented in its temporal and spatial evolution by mathematical models. Instrumental evidence on the present-day sea level changes are provided by tide gauges located along the Mediterranean coastlines. Their data shows a sea level increase of 1 to 2 millimeters per year during the last 100 years. Once they have been excluded from the data analysis, those archaeological sites located in geologically unstable areas or seismic and volcanic zones, whose crustal dynamics could have hidden the real estimations on the relative changes of the sea level, but which provide the values of the vertical movements produced by tectonics and volcanism, it becomes possible to calculate its changes due to eustatism and isostasy. Using mathematical models to compute the isostatic effect, it becomes possible to estimate that of the 135 centimeters of the average total change, 13 centimeters, 10%, are eustatic, and the remaining 122 centimeters, 90%, can be addressed to the global isostatic adjustment. The decreasing values of the isostatic effect away from the center of the ice sheets towards south and up to the North African coastlines seems confirmed by the first observations performed on the Roman Age coastal archaeological sites located in Libya. Their relationships with the present-day sea level shows changes related to the modern eustatism and only partially to the isostatic effect, as predicted by the mathematical model. This journey through time along the coastline of the central Mediterranean, between geology, archaeology and geophysics, has shown that the sea level has changed several times in the past. The archaeogeodetic and instrumental data show the slow and large movements of the Earth's crust occurring since the last glaciations, while the sea level rise seems to accelerate since the beginning of the early 1900s, at the same time of global warming, which started with the industrial age. What will be the future changes? Will the climate variations and the Earth's dynamics produce a continuous sea level rise at the current rates? And what will be the future impacts on human activities?